The International Space Station is being used by scientists from all over the world to conduct research that can support future spaceflight, but also to improve life for people on Earth. One such experiment now underway is using mice as stand-ins for humans to assess how well a new compound works to prevent skeletal muscle wasting and weakness. That's a condition that's faced by astronauts during a long-duration stay in weightlessness. Of course, it's also a condition that's experienced by many people on Earth. Recently, my colleague Amiko Kauderer spoke with Dr. Rosamund Smith. She's a research fellow at Eli Lilly and Company and is the principal investigator of the Rodent Research 3 mission. Amiko asked her to explain why the lack of gravity in space leads to weakened muscles for the station crew members.
Well, basically, our muscles are very responsive to the amount of resistance or load that they encounter. So, for example, when you lift weights and add more resistance, our muscles get bigger, right? But when one has less load or less resistance, as happens in the conditions of microgravity on our muscles actually decrease in size or undergo muscle atrophy or muscle wasting.
So we know it happens, and therefore we do have exercise equipment aboard the International Space Station. So astronauts are exercising, but tell me a little more about this compound that you are investigating to help as a possible countermeasure.
Well, actually, the compound we're developing is we hope to be able to prevent muscle wasting. Obviously, here at Lilly, we're very interested in developing this compound for muscle wasting conditions and diseases that have muscle wasting for patients on Earth. But obviously, it does have applications too for astronauts in space. So, yes, we're hoping that this compound will have activity to be able to prevent muscle wasting occurring not only in people with diseases that have muscle wasting, but also in the context of microgravity in space.
So you're studying mice in weightlessness. Can you tell me what makes mice a good analog for studying, muscle wasting in humans?
Well, actually, it's very interesting that the mechanisms of muscle wasting vertebrate species. So actually, mice are a very good surrogate and end up being a very good species to look at muscle wasting. Obviously, they're smaller, more convenient, and easier to do lots of different measurements. And so it makes sense, and we anticipate we'll learn a lot about what may happen in people by studying in mice initially.
Now, tell me about the hardware that is being used for this investigation, and what are the astronauts doing to help collect the data?
Well, ours is quite a complex experiment. It lasts 6 weeks. There's very specialized hardware just to get the mice up into the space station. They were in a specialized habitat in the transporter, in the Dragon rocket, the SpaceX rocket, Dragon capsule that took them to the space station. And also when they're sort of living in the space station, they're in a special habitat. So that provides them with food and water and controls the lighting and the temperature, etc. But then when we're actually performing our experiment, we also have other hardware, measures body composition, also the grip strength, which is a measure of muscle function in mice. There's a brand new way in which this has not been done before in mice on the space station. And to do some of those measures, we actually have to anesthetize the mice and to be able to measure their body composition. So that's another specialized piece of hardware that was designed to be able to allow us to undergo anesthesia. So this experiment involves a lot of hands-on work by the astronauts. I was very fortunate just a few days ago when we were at our 4-week time point in our experiment to go and watch the live feed from the space station and see Tim Peake doing the hands-on work on our experiment. And Tim Copra, the other astronaut, was doing measures for the body composition. So it takes quite a lot of astronaut time there. It's very complex measures, and so far, so good. We're already getting some exciting data.
So it'll be interesting hearing about the results of this investigation once it's over. And can you tell me, though, after studying the results, how do you hope that it will apply to astronauts, but also people living here on Earth?
Well, as you can imagine, if our experiment is successful and we are able to prevent the muscle wasting in mice in those conditions, it will be extra evidence that our compound can prevent muscle wasting. And of course, people include those data into our drug discovery efforts as we're working to develop new drugs and novel innovative drugs to help patients who have muscle wasting diseases on Earth. These are diseases such as muscular dystrophy, ALS, certain types of cancers that at the moment there's really no treatment for these muscle wasting diseases.
We wish you best of luck on this study. Thank you so much for joining us.
You're welcome. Goodbye.